Hi class, and welcome to your next video on pedigree analysis. Some of this is going to be a little bit of repeat from what we talked about in class, but go through each piece which will help you in the end with pedigrees. So first things first, in case you didn't have this in your notebook, we have squares for males and circles for females. Affected individuals are going to be filled in. If they mate, they're going to have a line in between them, and you're going to write the generations in birth orders. Identical twins are going to have the same symbol, male or female, and have this triangle. You're going to lose the bottom to the triangle with non-identical twins. You can have two males or two females with non-identical. All right, so the next thing I want you to do is I want you to practice constructing a pedigree. I know we did this in class, but we're going to practice this time with people who have a known disorder. So Mark and Laura are married, and Mark has hemophilia. So we're looking at hemophilia as our disorder. So anyone who has hemophilia, remember, should be filled in. Mark has 8 sisters. We don't know the birth order of any, so we're just going to draw his 8 sisters. And Mark's sister Elena has 4 children. She has 3 sons and a daughter, and 2 of her sons have hemophilia. We do not know the birth order here as well. His maternal grandfather also has hemophilia. Maternal grandfather would mean his mom's dad. And there's no history of hemophilia on Laura's side. So what I want you to do is to pause the video, draw this out, and then I'm going to show you the answer on the next slide. So here's your answer. Now, make sure that you have already drawn this, because it's not going to do you any favors and it's not going to do me any favors if you just copy this into your notebook. You're not learning by doing that. Even if you get it incorrect, you are learning by correcting yourself. So Mark is married to Laura, and he has his sister Elena, who we can assume is married, and they have 4 kids. Elena has 3 sons and a daughter, and 2 of her sons have hemophilia. Additionally, his maternal grandfather has hemophilia. So here's his mom, and here is his maternal grandfather. Here's your next one. Martha is about to have a baby, and Martha's mother, Megan, has ectrodactyly. Megan has 3 sisters, Jamie, Clara, and Jane. Clara is healthy and has 2 sons who are also healthy, and Jamie has ectrodactyly. She has 4 children, 2 girls and 2 boys. One of her daughters has ectrodactyly, and one of her sons has ectrodactyly. Jane is healthy and has 1 daughter. Her daughter Kate has ectrodactyly on 1 hand. Martha's maternal grandfather was healthy but passed away at the age of 60 from an unknown cause. Martha's maternal grandmother had ectrodactyly. So go ahead and draw this one out. And you're going to turn this one into me. So you're going to turn it in with your family pedigrees on Monday. So next we want to look at the different types of inheritance and how we can see different types of inheritance. The first type is autosomal recessive inheritance. So we know that it skips generations, and unaffected parents can have an affected child. But you might look at this and you might say, well, wait a minute. Generation 2 and Generation 3 and 4 and 5 all have people who have the disorder. So how is it skipping generations? Well, let's look at this. In Generation 1, 1 and 2 have 1 child that has the disorder. Now 5 is one of their children. And 5 and 6 get married, and they don't have anyone who has the disorder. But 7 here, from Generation 3, gets married and has 2 children with the disorder. So by that means we're skipping the generation, okay? So it doesn't necessarily mean no one in each generation will have it. It just means no direct descendants. So if we list the genotypes, so what I want you to do is to tell me what Generation 1, 1 and 2, Generation 2, 2, 3, and 5, Generation 3, 4, 5, and 7, and Generation 4, 1, 5, and 7, and Generation 5, 3, and 5 are. And here would be your answers. So remember, you're not just copying down the answers, you're trying and looking and figuring out why everything is the way it is. For this one, we see that the mom and dad here have a child that has disorder and is autosomal recessive. Anyone filled in is going to be little t's because we automatically know that they have the disorder and it's recessive. Mom and dad have to be able to donate that to them, so they have to be heterozygotes. If they're homozygotes, dominant, they cannot pass it on. They can only have kids who are heterozygotes, and we can't have a homozygote recessive because it's not filled in. So check your answers, and then we're going to go through autosomal dominant inheritance. So this one, if you have the dominant gene, you have it. So unaffected parents cannot have affected kids, and it shows up in every generation because it is dominant. So list your genotypes here, and pause the video, write them down, and check your answers. And let's talk about sex-linked inheritance. Sex-linked inheritance, we have sex-linked dominant and sex-linked recessive. In sex-linked dominant, fathers do not pass to their sons, and the affected father will always have all affected daughters. Now, in sex-linked, most males are affected. Mothers pass to both daughters and sons. So this is sex-linked recessive. Remember, you want to use your X and Y's in sex-linked, and your Y's do not carry anything. We're only going to look at your X's. So go ahead and write down the genotypes that are listed. Pause your video and check your answers. And this is sex-linked dominant. So remember, the dominant gene is the one causing the disorder. So go ahead and write down your genotypes and check your answers. And now we're going to look at what types of inheritance each of these are. So go ahead and look at this. Now remember, this right here, this line right here, double line, means that they are related. They might not be brother and sister, but they might be cousins, and we are going to look at that. This is autosomal recessive. The reason being is we have a father and a mother who do not have children have it, but we also have a father and mother who have two children that have it, that do not have the disorder. Go ahead and look at this, and this one is sex-linked recessive. So we see all males that have it, and so mothers have to be the carriers here. And look at this one. And this one is autosomal dominant. The reason being is we don't see, if you look at this one here, this male is passing it to his son. And males cannot pass to sons, and he has a daughter who does not have it, which means it is not sex-linked. It has to be autosomal. And look at this one. And this one is autosomal recessive again. We see parents who don't have it having children who have it. And the last one. This one is sex-linked dominant. We see dad here has it, and each of his daughters, ones that have lines coming from him, have it. And mom has it here, and her daughter and her son have it. All right, so make sure you took great notes. Make sure you have the answers, and make sure if you're having trouble, you review it. I'm going to put a practice video online as well. And then also complete your family pedigrees from the pedigree assignment.